Let me say a few things about the measurement devices, ampermeters and voltmeters. Let's remember that the ampermeters measure the currents on branches, and voltmeters measure the potential difference between 2 points. So therefore, you have to think about these when you are connecting these devices. So an ampermeter is connected in series with the circuit. So on the branch that you would like to measure the current, you place the ampermeter, right? And voltmeter, if you want to measure the potential difference between these 2 points, you have to connect the voltmeter like that, right? One of the important things that you should keep in mind is that these are devices that have some resistances and internal resistances. So you would like to adjust these values in such a way that when you connect them to the circuit, you don't want to disturb the circuit too much. So as a result, an ampermeter, which is connected in series to the circuit, should have ideally almost negligible resistance. So let me write it down like this. The internal resistance of the ampermeter should be as small as possible. So it should be much smaller than the resistance of the other devices, or the total resistance in the circuit in here, so that in that case you can have you can claim that there's a negligible resistance. In contrast, the voltmeter is connected in parallel, and so therefore it just draws some additional current over itself. So you would like this current to be as small as possible, which means that the voltmeter should have an internal resistance which should be very large compared to the resistance of the device that you're actually trying to measure the potential difference. All right, but of course there is no ideal zero resistance or an infinite resistance. So all of them have some non-zero resistance. So as a result, when you connect an ampermeter to a circuit, you're always changing the circuit. So therefore, you're not measuring the current that you would like to measure. So this is basically the current that flows when the ampermeter is not there. And similarly for the voltmeter. So whenever you are measuring something, you're always disturbing it, right? So that's one of the differences between these two devices. And the other thing is about the internal structure. Usually these are built from galvanometers. Galvanometers are essentially ampermeters, but they are measuring very small amounts of currents of the order of, let's say, 1 microamperes. So as a result, if you want to build an ampermeter by using such kind of a device, you have to somehow make sure that there is a very small amount of current passing through the galvanometer. So that's how we usually do. So let's say that you would like to build an ampermeter, let's say. Let's just remember that this will have almost negligible resistance. So as a result, you just build it like this. You just connect two devices. Let me write it down like that, right? You just connect two resistors in parallel, and one of them is connected in series with the galvanometer. So you want to make sure that this resistance in here, which is in series with the galvanometer, is much bigger compared to the other resistance. And so as a result, whenever a large current passes over the device, which passes over the ampermeter, only a small portion of that current passes over the galvanometer branch, so that the galvanometer would read negligible current. So let's say it like this: a galvanometer measures a microampere current, and you would like to measure currents of the order of 1 amperes. So as a result, you can see that this R should be of the order of about 10 to the 6 times the other resistance, so that a 1 ampere current that flows from the main branch will have a current produced on the other branch, which is of the order of 1 microampere, right? So, and the second thing is, of course, this internal resistance of the ampermeter is, let's see, these are connected in parallel, so therefore the resistance is given by the reciprocals. So let me just see it like this. The reciprocals are added up, which means that in that case the small resistance is equal to, or almost equal to, the resistance of the ampermeter. For the case of a voltmeter, of course, this is kind of easy to see. Use a very large resistance in series with a galvanometer. So this is, right, R is very large. So of course this is equal to the internal resistance of the voltmeter. This has to be very large in any case. So only in that case there will be a very small amount of current passing over the voltmeter, and so therefore the galvanometer can read this easily.